Chapter 5, Section 4.1, Part 3's video. This table shows the growth factor for a number of different populations. For each population, find the percent growth rate. Okay, so what they're giving us here is the bees. Okay, the bees. So we know it's above 1, so therefore it is a growth, and that's what the rest of these appear to be. So we've got B equals 1 plus R, right? So 1.6 equals 1 plus R, so minus 1, so 0.6 equals R, which is equal to, if you take 0.6 times 100, or just move it 2 places to the right, decimal, you get 60%. So 60%, right? 0.6 times 100 equals 60. All right, so let's kind of do a little bit quicker than this. B minus 1 equal to R. So if I take the 1 over to the other side and solve this equation right here in terms of R, then it's B minus 1, right? So that's good. I can speed things up, right? So 0.04 equals R. Multiply that times 100. Or just move it 2 places, right? And that would just be 4%. Okay. I think you kind of get the gist of this. And some of you might be able to go, oh, well, that's 1 minus, so it's just 0.55. So do that times 100, or just move it twice, so 5.5 equals R, right? All right, so that kind of gives you an insight on that one. Okay. Laws of move this down. There. Okay. Laws of exponents, right? It says, let's see, a to the n times a to the m is a to the n plus m, right? For multiplying like bases, we have their exponents. So here you can see that these are like bases, okay? So that would be 3 to the x plus 4, okay? Now, anytime you have a base raised to a power raised to another power, that's like taking these and multiplying them. So that would be 3 to the 4x, right? X times 4, 4x. Now, what happens if you just have no like bases? Like this, 3 to the x times 4 to the x. Well, you just multiply the coefficients, right? So that would be 12 raised to the x. So there. Now let's look at this one. This one goes back to, I think, the second page of the very first video, where it talks about getting 2 points, like initial point, some other point, in some elapsed time. Can you find the growth rate and all that other stuff? I think this one follows that. So the Riverside County is the fastest growing county in California. In 2000, the population was 1,545,387, right? A formula for the population of Riverside County. Use the letter B for the growth factor, for which you do not yet know, and t equals 0 represent the year 2000. So what they're doing is they're doing a couple of things. We're resetting the clock, so t equals 0 at 2000, right? There's my initial. So basically, all I have to do times b raised to the t. And that's it, because they said we didn't looked at the growth factor yet, and just t equals 0, right? So there. Now, part B. In 2004, the population had grown to 1,871,950. Find the growth factor, which is B, and then the growth percent rate, which is R. Okay, so this comes back to what I was talking about earlier in videos. It's new over initial, right, raised to 1 over elapsed time. How long did it take to go from the initial to the new? Okay, so when we're doing this, the new point is 1871950 divided by the initial amount was that. Now that was in 2000 and this is in 2004. So that's 1 over 4, right? 1 is always going to be there over the elapsed time. It took 4 years. Okay, so you just got to be able to do this on the calculator on the screen because there's too many numbers. Well, let's see if I can do this. I have to go between some things, but I guess it'll be okay. Clear that. Okay, so I'm going to get a parentheses, and I'm going to do 1871950. 1871950 divided by 1545. 5387. Close parentheses, raised to the parentheses 1 divided by 4, close parentheses, boom. And I've got my set up for 4 decimal places, okay? So I want you to kind of see that. Okay, so I'm going to kind of scroll this down a little bit. Oh, shoot. Okay. Now, so here's my answer for my B, right? So it's 1.0491. Now, if I take that and just go minus 1, that's taking that answer minus 1, I get 0.0495, right? So this would be 1 minus, oh shoot, 1 minus 1.0491, which equals 0.0491. Go to this. Yeah, that's how they've got it, right? I wanted to show you that. And then it would be, if I move it 1, 2, 4.91, right? Growth percent rate is 4.91. And then predicted in 2010, and that 2010 is 10 years from there, right? So what I have is 1545387 to 1.0491 raised to the 10th power. Okay, so I got that out. And when I do that, I get, I'm going to do it on 1545387 raised to, sorry, boop, times 1.0491 raised to the 10. And on my calculator, I get this, and I'll put this, kind of show you. I get 24957 78.993. And you know what? I just put it all. There. Now, I'm going to show you what they got as answers. Well, they didn't show the bottom answer, that, but you can look and see they didn't round to there. They kept it as 0.9. They rounded to a different place, and then 4.91 is 4.909, right, which is 4.91. So there, we've got the same thing. It's just the way they've got it. And I wanted to show you the first part. Said they got it in scientific notation times b to the t. That should be plenty good. So let me go back one. Okay, done that one. Okay, so 1, 2, 3, 4. Okay, so I want to look at this one. It says the table describes exponential growth or decay. Find the growth or decay factor. Complete the table. Round your values to 2 decimal places if necessary. Okay, so what you have to understand is, kind of goes back to the previous problem. These are all going up by ones, right? So if I got elapsed time, that would be 1 over 1, which is just 1. So it's 36 over 30, okay? So it's the previous, it's the initial divided by the previous one, right? So what you have new divided by the initial, right? And the reason why I'm not going to do it in 1 over 1, well, 1 over 1 is just 1. Um, uh, so that kind of gets back to this equation, the new over initial raised to the 1 over elapsed time. That's kind of what you're doing here, but as long as your x's are going by 1, you take this one divided by that and you should be fine. So 36 divided by 30 is 1.2. So let me do this real quick, because 36 divided by 30 is 1.2. So if I take 30 and multiply it by 1.2, I get 36. If I take 36 times 1.2, let me show you what I've got. So 30 times 1.2 is 36. If I do times 1.2, that takes 36 times 1.2. That's 43.2. If I do times 1.2, if I can hit my right buttons, 2 gives me that, times 1.2 times 1.2, and it just kind of fills out because it's the previous value times 1.2. All right. So you got to make sure you kind of understand that about exponentials. So, and when you hit, especially on these TIs, when you have the answer, if you'll just do your operation that you want that answer to be the first part of, it'll take the answer you had previously and do that, okay? So let's go back here. So that's 43.2, and that would be 51.84, and that's 62.208. And that's what we got here. If you look at all these, we got that. So you can do that by. Now the growth or decay factor is 1.2. It's a growth. Reason growth is 30 to 36 went up. If it was going down, like 30 to 25, then that would be decaying. But since the next point was higher than the previous one, it's a growth. If it was lower than the previous one, it'd be a decay. So just kind of notice that. All right. So I wanted to do this one, and then this right here would be the end of part 3. And I left the answer up here because I just kind of wanted you to see it. Francine says that if a population grew by 60% in 6 years, then it grew by 10% per year. Well, that's not correct. So it grew by a sixth of 60, which would be crazy. So is she correct? And the answer is no. A justified calculation. Well, 60%, right? So that's an R is 60%, which is really 0.6. So it's 1 plus R, so 1 point plus 0.06, which is 1.6, right? That's our base. Now, that'd be 1.6 to get it back to a base. 1 overlaps time, right? So 1.6 raised to the 1/6. So that's 1.6 raised to the parentheses 1 divided by 6, right? That would give me, and I'll show you the same exact calculations, 1.0814837, right? It gives me all of that. Now, that's that's my B. If I subtract 1, so if I go minus 1, that's going to give me 0.0814837, which would be, if I move that over 1, 2, that'd be 8.148. Okay, and if you wanted to go to 3 decimal places, it'd be 8.15, because you'd hold that one in that 8, make that 4 go up. Okay, so there you go. All right, so this is the conclusion of Chapter 5, Section 4.1, Part 3 video.